Well, howdy there, partner, and welcome to our fourth class of Unit 2. For today, with almost all of the fundamental skills that we need to solve any inequality of our choosing under our belt, haha belt cowboy, that leaves us with only one thing left to do. Let's dance. No, let's put it all together, shall we? Scream as much as you want, protest all you want, I can't hear you. Your resistance is futile. Class 4, Unit 2, let's chat about solving some multi-step inequalities. Part 1. So on the board, 7 plus the quotient of a number in -6 is at least 1. Couple tasks for you. First off, algebraic representation, let's turn this into symbols. Second off, let's solve for whatever variable you choose using your properties of inequality. From there, let's graph our solution set on the number line, and then finally, we'll write that solution set in both set builder and interval notation. Give yourself 2 minutes, see how far you get. Have at it. Have you had at it yet? If not, you're going to have at it now. Let's take this step by step, reading from left to right. 7 plus quotient, I don't remember. No, I'm kidding. Quotient, of course, gives me the operation of division. Well, what am I quotienting? I've got a number in the first slot. Let's call it n, and -6. And from there, I know that that is at least again, think of your translations this time, at least think of it like a minimum, right? I can't go below that minimum. So I could be greater than my minimum. I could be equal to my minimum, but I cannot be less than. I can't go below it. And then my 9 on the other side of my inequality. So 7 plus n over -6 is greater than or equal to 9. Let's solve for n. So we saw from our properties of inequality, just like an equation, the idea of inverse operations, with one small exception, works exactly the same way as we would expect. So let's take our 7 in this case. Think of my sad bet, my reverse order of operations. In this case, I've got some AS that I can get rid of before some MD. So I'll minus 7 from both sides. 7 minus 7, these go away. I've got n over -6 is greater than or equal to 9 minus 7, which is 2. Last thing standing between me and n by itself is that pesky -6. It's connected by division. Let's undo it by multiplication. I've got, in this case, my -6's undo each other. N is greater than or equal to -12. And then I'm done. No, I'm not. What did I miss? What did I do? I did something wrong. I'm a failure. No, I'm not a failure. I'm just silly. Notice here, what choice did I make? Well, I multiplied by a negative number. And when I multiply by a negative number, what happens to my inequality symbol? 5, 4, 3, 2, 1. It spontaneously combusts. No, it does a little backflip. So I'm going to take my inequality symbol. Instead of greater than or less than, because I used a negative number and did some multiplication or division, I need to flip it to a less than or equal to. So n is less than or equal to -12. Finally, let's graph it and express it in our notations. I've given you a number line, and would you look at that, it's already labeled. Not because I wrote the problem, but because much like Apollo, I was gifted with prophecy. So I know -12 is the thing that my inequality revolves around. I'm interested in graphing values of n. -12 is always going to get circled here. What question do I need to ask myself again about whether that circle gets filled in or left blank? Thanks, invisible person. Well, I need to ask, is -12 in or out of the solution set? Because it could be equal to, it is in the solution set. Just like a chest bubble, I bubble in my circle. And now n here needs to be to the left, right? It needs to be less than or equal to that -12. So I'll shade in everything to the left of -12 on my number line. Cool. All I've got to do now is write my notations, my set builder, my Smash Bros, and my interval. Set builder notation. Remember, it always starts with a squiggly bracket. I'm interested in the collection of all values of n such that my vertical bar, he's got bars, n here, the only criteria to be in my solution set, it needs to be less than or equal to -12. Close it with my n squiggly bracket. Interval notation, again, I'm asking what part of the number line am I interested in? What have I shaded in? Well, on the left, there's no clear start point. I'm going all the way off to -infinity. And on the right, I end at -12. Just need to ask about parentheses and brackets. Well, -infinity never included. It's a concept, not a number. Always gets a parentheses. Negative 12 has a closed circle. It's in my solution set. Oh, I'm dying. It gives me a bracket. Very good. So with this idea in mind, let's amp up the ante a tiny bit. From here, let's take this guy. Negative 2x plus 3 is less than x plus 9. I want to solve this guy for the variable x. I want to graph it on the number line, and I want to write my notaciones. Go ahead, give yourself 2 minutes. See how far you get. Let's solve for x, graph it, and write our set builder and interval notations. Go, go, go. And stop. Well, first of all, I hope you noticed there's something different about what was written here from what was written above. The difference, of course, being I've got x's on both sides. So I need to find a way to move all of my x's to the same side. In this case, maybe I'll start by adding 2x to both sides. Could I subtract x from both sides? No. Just kidding, of course you could. Absolutely. Lots of great opening moves to make. This is only one of them. So, in this case, on the left side, the 2x's cancel out. I'm left with 3 is less than x plus 2x is 3x plus 9. Inverse order of operations, SADMAP. Let's do our, not 9 is 6. I'm going to get rid of 9 on both sides. In this case, on the right side, they undo each other. 3 minus 9, there's my negative 6, is less than 3x. Last thing I need to do to get x by itself, well, 3 is connected by multiplication. We'll undo it with division. Again, I should always ask myself if I'm doing division, does my inequality need to flip? Well, even though the negative 6 is negative, the thing that I'm dividing by is positive, so does my inequality change? No. So here, I've still got a less than, x is on the right, and negative 2 is negative 6 divided by 3. So there's our inequality. Negative 2 is less than x, or equivalently, again, we've got a reciprocity, x is greater than negative 2. On the number line, well, I want negative 2, so I'll give myself some tick marks. We're going to pretend they're evenly spaced. In this case, I'm interested in values of x. I know that negative 2 needs to live on my number line. Maybe I'll say negative 1 and negative 3 to give myself some indication of scale. Give myself some ellipses because I'm lazy. From here, I've got negative 2. Negative 2 is always going to get circled. Am I going to fill in my circle here? Yes or no? 5, 4, 3, 2. Lift off. Well, negative 2 is not in my solution set. It's not a less than or equal to, so my circle stays open. In this case, even though x is on the right side, don't fall into the trap, right? It is on the bigger than side of the inequality symbol. I need to be to the right. Last move. Let's write our notations. My Smash Bros. Well, I've got the set of all values of x such that my criteria, well, I said negative 2 needs to be less than x. Equivalently, I know I can write x is greater than negative 2. And finally, my interval notation. What part of the number line did I start with? Well, on the left, I started with negative 2. I go all the way off to the right, so I'm going towards positive infinity. Positive infinity never included gets a parentheses. Negative 2 has an open circle. It's not included. It gets a parentheses as well. Cool. Let's do 2 more for the road. So with these ideas in mind, a little bit more challenging, but nothing you can't handle. Let's take these 2 inequalities, solve for your variable, graph on your number line, and give me your set builder and interval notations. Go, go, go. Alrighty, stop, put your hands up. Put those hands where I can see them. Turn around slowly, drop your weapon. Okay, 8b minus 3 is greater than 4, parentheses 2b plus 3. So, first thing I notice are parentheses. I probably want to get rid of them. 8b minus 3, in this case, if I distribute on the right side, is going to be greater than 8b plus 12. Now, hopefully when you were solving this problem, you raised your eyebrow a little bit at this. Me giving you something I didn't explicitly tell you and asking you to figure it out for yourself. Imagine that, the horror, the humanity. No one has suffered like you've suffered. Well, in this case, when I saw something like this with equations, usually my equation turned out to be a little funky. Let's see if this gives me a funky inequality. Well, issue, same as before, I've got b's on both sides. I want to get rid of 8b. I'm not going to act like I don't know what's going to happen here. 8b minus 8b, as much as you love my acting, it's going to cancel out on both sides. So I've got negative 3 left over on the left. greater than 12 on the right. So, just like with our funky equations, all of our variables went away, which means I need to take this statement, this -3 is greater than 12, and ask a question. Well, even just reading it, hopefully you can figure out what the question is. What do you think I need to ask here? Remind me. Go. 10 seconds. 5, 4, 3, 2, 1. Well, if I'm trying to make sense of this, the question that I should ask, remember, the goal of solving is to make the inequality true. So the question I should ask is this a true statement? Is -3 greater than 12? Well, no, a negative can't possibly be bigger than a positive number. So this is a statement that's fundamentally false. Nothing can make -3 greater than 12. This is incorrect. It's false. It's never true. How many solutions do you think that gives me? Very good, invisible person. Well, if it ain't broke, don't fix it. If I can't make it true, just like an equation, it has no solution. So I can write this here using my funky symbol. I can write no solution, whatever you want. Now the question becomes, how do I graph that? How do I write that in my notations? What do you think the graph of something with no solution looks like? What do you think its interval or set builder might resemble? Take 30 seconds. Try something out. See what sticks. Alrighty, is it sticky? I hope so. So, in this case, let's take this no solution. If I want to graph it on the number line, remember, I'm interested in charting values of b, so I'll label my b. But to indicate the solution set, I shade in the things that make it true. In this case, nothing makes it true. So, nothing on my number line should get shaded in. There's your graph. It's just an empty number line. No values on the number line will make it true, so nothing should get shaded in. Our set builder and interval notations are slightly wonky here, but that's fitting because the inequality is wonky. Set builder notation, remember that this symbol here for our no solutions that we use interchangeably, it doesn't mean no solutions. It is the empty set. So because it is already a set, and I'm talking about set builder, there is one way to write your set builder notation. You can just use your little O with the slash through. Equivalently, I could also write the empty set. Well, remember I used my squiggly brackets to define it. In this case, there's nothing in that set, so I could also just write the empty set like that. It's the set with nothing in it. So it's got my squiggly brackets, but nothing contained inside. For interval notation, I usually say that it does not have an interval notation. Because trying to figure out where I start and end is kind of weird. So my interval notation, I usually say it doesn't exist. If you want to know how to write this in interval notation, the idea is that nothing is included. So on both sides, you're going to use parentheses. And then you just pick a number. So maybe you say 0. So if I want the interval that goes from 0 to 0, well, that's just 0, but then 0 isn't actually included in either case, so I'm going to use parentheses on either side. This is one way, in a kind of weird roundabout way, to indicate that nothing on my number line is getting shaded in. I don't like this notation. I find it confusing. I usually say that it does not have an interval notation, but technically, there you go. There's one way to write it in interval notation. Great. Take the one on the right. If you haven't already solved it, give yourself some time with what you've got in mind from this one on the left. If you have already solved it, don't bother pausing. Let's do it together. So 2 parentheses 5w minus 1.2. Let's distribute on the left side. 2 times 5w gives me my 10w. 2 times negative 1.2 gives me negative 2.4. Less than or equal to. On the right side, notice I've got some like terms I can combine. 14w minus 4w is 10w plus 7. Alarm bells, alarm bells, alarm bells. I see 10w on both sides. Same issue as before. I want to get rid of the w on one side, but it turns out that getting rid of 10w on one side also gets rid of 10w on the other. So I'm left with negative 2.4 is less than or equal to 7. Same question as before. What should I ask once I get to a point like this? 5, 4, 3, 2, 1. So in this case, I should ask, Is this true? Well, is negative 2.4 less than or equal to 7? Well, yes, all negatives are smaller than all positives. So this is a true statement. It is less than. Let's think here about what that means for my inequality. This statement is fundamentally true. It's always true. Nothing can make it not true. In this case, what does that mean for my solution set? Well, that should tell me that everything is a solution. But something about the way we're going to talk about it needs to change a little bit. I can still use this notation, my all real numbers, but I would not say that this inequality has infinite solutions. Why do you think I wouldn't say this has infinite solutions? 10 seconds. Okay, well, hopefully you remember, we said by default, any inequality usually has infinite solutions. So it would be a little bit redundant to say that this has infinite solutions. That's not special. Every inequality does. So the way that I would write this, if I don't want to write my all real number symbol, I would actually need to write all real numbers. You could write numbers out. You could use your pound symbol. It doesn't really matter. But I can't say infinite solutions because, again, every inequality by default will usually have infinite solutions. How could I graph something with all real numbers, everything as its solution set? And what might its set builder and interval notations look like? Take 30 seconds, try something out, see what happens. Go. And stop. Well, for all real numbers, that means anything works. So on my number line, everything should get shaded in. There's nothing on my number line that can make negative 2.4 not be less than or equal to 7. So the entire number line here gets shaded in. I'm not even going to bother to label it with some tick marks. It's the whole thing. Set builder notation, just like for our no solutions, I can use my funky symbol. Remember that bold R means the set of all real numbers, so I can write that as my set builder. Interval notation we do actually have. Well, think again about start and end points. On the left, where do I start? Well, I don't really start anywhere. I go all the way off to negative infinity on the left and to positive infinity on the right. If you figured that out for yourself, great. If you didn't figure that out for yourself, also great. If you figured out the no solutions and all real numbers for yourself, great. And if you didn't, who cares? That's totally fine. Lovely. So one of the sacrifices that we make by trying to prioritize shorter videos is that we don't get to do as many practice problems. So here are 3 more that I would have liked us to do together. We'll say these will be our warm-up when we see each other next time. If you want a little bit more practice in between, feel free to tackle them, and then we'll chat about them once we find ourselves together next time. Alrighty, my dears. Have a wonderful rest of your day. Thank you for bearing with me. I will see you for Unit 2.5. Goodbye. Or I guess I should do a cowboy goodbye. What would a cowboy say? Like, hasta la vista? I don't know. That sounds... Well, I didn't do it in an Arnold Schwarzenegger. I'm going to be quiet. I'm not funny. Goodbye!